In this video, we're solving International A-Level Physics, Unit 2, October 2025, questions 11 to 14. I'll walk through each step clearly, explain the examiner's logic, and show you how to write answers that will score marks. Let's start with question 11. A wire of cross-sectional area 2.8 times 10 to the power minus 6 meters squared is connected in a circuit. There is a current of 2.5 amperes in the wire. Calculate the drift velocity of the electrons in the wire. And we're given the number of charge carriers per unit volume as 8.5 times 10 to the power 28 per meter cube. So we will have to use the transport equation here. The transport equation is I equals NQVA. The number of charge carriers is 8.5 times 10 to the power 28 times charge of electron 1.6 times 10 to the power minus 19 times the drift velocity that we have to find times the area of the conductor, which is 2.8 times 10 to the power minus 6, and the current is given as 2.5. To find the drift velocity, we just have to divide the current with everything else. And this comes out to be 6.5657 times 10 to the power minus 5. 6.57 times 10 to the power minus 5 meters per second. Question 12 says, a coffee machine is connected across a 230-volt power supply. The heating element in the coffee machine has a resistance of 18 ohms. The coffee machine takes 38 seconds to heat enough water to make 1 cup of coffee. Calculate the energy transferred by the heating element in 38 seconds. So we want to find the energy transferred. The energy transferred is equal to the power times the time. But we don't know the power, but we have the voltage and the resistance. The power can be found by multiplying the voltage and the current, but we don't know the current. From V equals IR, current can be written as V by R. That's our current. And now if we insert this in the power equation, we get V into V by R. And so power comes out to be V squared by R. So that's another formula we can use for power, V squared by R. And if you're not given the voltage, but you're given the current and the resistance, we can find the power from P equals I square R from this formula. But for this question, we need V squared by R. So that's going to be V squared by R times the time. And that's going to be 230 squared divided by 18 times 38 seconds. And this comes out to be 1.12 times 10 to the power 5 joules. 1.12 times 10 to the power 5 joules. Don't forget the units. All right, question B says, explain why the resistance of the heating element increases as its temperature increases. So when the temperature increases of a conductor of a metal, the lattice ions start to vibrate with a greater amplitude. And so the collisions between the electrons and the lattice ions would increase per second. And so the increase in temperature increases the resistance. So increasing the temperature, the lattice ions vibrate with greater amplitude, or you can just write more rapidly, right? This increases the rate of collisions, the rate of collisions between the electrons and the lattice ions. And so the resistance increases. So the resistance increases. Question 13 says, a student determined the resistivity of a metal in the form of a wire. The student measured the resistance for different lengths of the wire. So he measured the resistance for different lengths. She plotted the graph as shown, resistance versus length, and we have a straight line that's not going through the origin. The table shows the resistivity for some metals. We have three metals, constant 10, nichrome, and copper, and their resistivities are given. Deduce which of these metals the wire was made from. The diameter of wire is 0.44 millimeters. I want to convert this to meters first. 0.24 times 10 to the power minus 3 meters. So the idea is to find the resistivity of the given metal wire and then compare with the metals in the table. The one with the closest value will be our wire. Okay, so the resistance versus length graph can be used to find the resistivity because the resistance is equal to rho L by A. We have drawn a graph of resistance, which is the y-axis, and the length, which is the x-axis. So rho divided by A is going to be the gradient of the graph. So the gradient of the graph is rho divided by A. So the resistivity is going to be the gradient times the area of the wire. And we're going to use this to find the resistivity and then compare with the values in the table. So the resistivity is the gradient times the area. The gradient can be found from the graph. I'll write the area first. Area is going to be pi r squared. The radius is going to be half of the diameter. So 0.24 times 10 to the power minus 3 divided by 2 whole squared. That's going to be the area. And the gradient can be found from the graph. We'll take any 2 points. We take at least half of the provided graph. So I'll just take the largest possible triangle. I'll take here. I'll take this point. So this is 9.8, and that's 1.2, and this is going to be 80. So the gradient is going to be 9.8 minus 1.2, that's the height of the triangle, divided by the base is 80. The base is given in centimeters, so I want to convert this to meters, so multiply by 10 to the power minus 2. So that's the gradient, and the gradient is 9.8 minus 1.2 divided by 80 times 10 to the power minus 2. And if we insert this entire thing in the calculator, we will get 4.86 times 10 to the power minus 7 ohm meters. And if we compare with the table, we can see that 4.90 is the closest to 4.86, and so we can write this almost equal to 4.90. Therefore, the wire is made from constantin. Okay, so that was question 13. Question 14. A student used a semicircular glass block to investigate the refraction of light. He directed a ray of light onto the glass block as shown. State why the ray of light does not refract as it enters the glass block. So as the light ray is entering the glass block, it is not refracting because it hits perpendicularly to the surface. The angle of incidence is zero, so the angle of refraction will also be zero. So we say that the light ray hits the surface perpendicularly. Perpendicularly. Or we can write along the normal. Along the normal. That's also the same thing. Okay. The glass has a refractive index of 1.5. The ray of light is refracted at the curved surface of the block. Calculate the angle of refraction. So we're given the angle of incidence, which is 35. We're given the refractive index, 1.5. We want to find the angle of refraction. And it's going from glass to air, so the index of air is going to be 1. So we're going to use the Snell's law, n1 sine theta 1 equals n2 sine theta 2. So n1 is 1.5, is going from glass to air, so n1 is 1.5, that's the index of the glass, times sine 35, that's the angle of incidence, and n2 is 1 times sine theta 2. So theta 2 is going to be the angle of refraction. That's going to be sine inverse 1.5 times sine 35. And if we insert this in the calculator, we get 59.4 degrees. So the answer is 59.4 degrees. That's the angle of refraction. Part B2 says complete the diagram to show the path of the ray of light as it leaves the glass block. So it's going from less dense to more dense. Oops, sorry. It's going from more dense to less dense. So the ray of light is going to refract away from the normal. So it's going to go away from the normal. And this angle is going to be 59.4 degrees. We don't have to measure this angle because it's just one mark. If we had two marks, then I would measure the angle of refraction. Part C says, the student moved the glass block so that the ray of light was incident on the curved surface at the critical angle as shown. So the angle of incidence is now the critical angle. Determine the distance x. The index of glass is 1.5 and the radius of the glass block is 45 millimeters. So the radius is going to be 45. So I'll write this as O, that's our A, and the point where the light ray hits the surface is going to be point B, and that's going to be point C. So we have to find AB. We have to find the length AB. Distance x is just AB. That's AO plus OB. AO is the radius of the semicircular glass block. So that's going to be the radius plus OB. Now we have to find OB. The line OC is also the radius of the glass block. So that's going to be R. And OB is our length to find. And the angle of incidence is the critical angle given. So we can use sine theta. Sine C is equal to opposite by the hypotenuse. Opposite is OB and the hypotenuse is R. So OB is going to be R into sine C. And we know that sine C is going to be 1 by n, and that's R into 1 by 1.5. That's going to be our OB. So that's going to be R plus R times 1.5. And the radius is given as 45 millimeters. So 45 plus 45 times 1 by 1.5, and so that's going to be 75 millimeters. Distance x is 75 millimeters. Okay, so we had to use some trigonometry, and the formula n equals 1 by sine c to solve this problem. Okay, so we're done with question 14. We'll be doing question 15 and 16 on the next video.